is Dan Kessler. I'd like to share with you a new product design I've been working on. It's called the Fractional Power Gas Solenoid System. The Fractional Power Gas Solenoid System was designed to provide gas flow control in non-powered gas appliances from a small DC power pack or battery pack. The system consists of two parts, solenoid and the control board. Solenoid uses a low voltage, low power, compact actuator that was designed for appliance applications. It has a wide operating temperature range, 0 to 120 C, and its compact size offers flexibility in the design of the solenoid body, which could be brass or aluminum. Because of its size and profile, assembly to the body is quick and robust. Because the actuator is low voltage and low power, it also requires an energized signal. The energized signal is created on the control board. When power is applied to the control board, it provides the correct operating voltage and power to the actuator. At the same time, it begins producing the energized signal. In a short period of time, it will verify that the energized signal is correct and send it to the actuator, causing the solenoid to open and allow gas flow. Once the actuator is energized, the circuit will then go into a sleep mode, reducing the current draw of the control board to 1 milliamp. The circuit on the control board was made using common, discrete, and passive components, and has a low parts count. The operating temperature range is 0 to 105 C, although I do believe we can get 120 C rating. In production, the control board would be made using surface mount technology, making assembly fast and reliable. The two parts of the fractional power gas solenoid system combined, the solenoid and the control board, require less than 1/4 of a watt of power. This provides extended operating time in your application. So let's go to the lab and see how it works. Got the solenoid mounted to a small bracket here. The inlet connected to a gas source through a gas grill regulator. The outlet of the solenoid has a orifice that feeds gas to this oven burner. The oven burner has an electrode on it, which we're going to use for ignition. And that's connected to a 9-volt battery module. The actuator is connected to the outlet of the control board. And we have a small battery pack connected to the inlet of the control board. There's a little power switch here. Battery pack is 4 AA alkaline batteries. And what we're going to see is when I turn the power on, we're going to see a small delay as the circuit goes through the overhead of creating the signal for the solenoid. Once it detects that it's generated that signal, it will send it to the actuator and cause the solenoid to open and allow gas flow. The circuit then goes into a sleep mode, so we reduce the power draw on the battery. Let's see how it works. Power on, small delay, gas flow. Turn it off, solenoid shuts off. turn on, small delay. Turn on, small delay. Now right now the circuit is only drawing about 1 milliamp of current, which keeps the current draw in the battery very low. And again, the default position of the solenoid when power is removed is closed. Okay. Alright, let's connect the power supply instead of the battery pack. And we'll set the power supply for 6 volts, which is what we would expect a 4 alkaline batteries to read when they're new. Doesn't matter, it could be a little bit more, a little less. Okay. And we'll turn it on. Alright. Now let's go down to about 4.5 volts. That's about 25% usage. Okay. Now let's go down to about 3 volts, which would be about half-life of the battery pack. Maybe a little less. Okay, again, a little delay. And a little delay. And just to show you how little power this circuit draws, or the system draws, I'm going to disconnect the actuator. And I'll show you by plugging this LED in. As you can see, the actuator and solenoid doesn't draw any more current than it takes to light a single LED. We're back. Now you've seen how the fractional power gas solenoid system works. With your interest and support, we'll be able to offer manufacturers of non-powered gas appliances the opportunity to look at electronic and electromechanical controls for their appliances. I look forward to your questions, suggestions, and comments. Please email them to Fpgss at drkdesigns, one word, .com. Thank you very much, and again, thanks in advance for your support.